Hi there, Stuart from Riku here. Today I am sitting down with Jacopo from Lighton to talk about AI and Muse API and some of the things that they have been up to. He is the lead machine learning scientist at Lighton, so it should be fairly interesting. Before this talk, we asked the community to give us some questions that we could give to Jacopo, and we have got some questions to ask. So let's get into it and get into those questions. So the first one from the community was, how do the language models that Lighton have created compare to the larger models such as the GPT-3 ones from OpenAI?
Hi, Stuart, and thanks for having me. So let's start with the answers. So the real added value of the models that we have in Muse, in the Muse API that Lighton offers, is the fact that they are natively trained in the language that you need. So if you need English, French, German, Italian, Spanish, you don't need to go through an English model and then a layer of translation, but you go directly to the language, which means two things. First of all, you need one tool less because you don't need a translation tool anymore. And the second thing is that we find that using models that are trained natively in the target language is much more natural, especially for native speakers. You avoid like cultural idiosyncrasies, like, for example, you are French and you don't see the weight of a cat in pounds, but you see it in kilograms. Or if you're talking about speed limits, it talks in kilometers per hour and not in miles per hour. Even things that are very cultural, like, for example, one of the things that we found out is that if you ask our French model, Lirefer, about unpasteurized cheese, it's gonna produce content like, okay, this is amazing, it's an incredible food, you should eat it for sure, you need to take care of like bacteria and this kind of stuff, but everything is done properly so that there is no danger to health. And instead, if you go through an English model that's most of the time US-centric, plus translation, you will have content that's generated that's like, you should absolutely avoid this. It's very dangerous for health, which is an attack to French culture because like you cannot attack French cheese. So these kind of things, if you have a model that's trained natively, you avoid them. And we have published a blog post about this that's on the importance of natively trained language models, where we go through a list of examples, of similar examples. It's mostly focused on French against English plus French translation, but it's to get an idea.
Yeah, that's interesting to know because, yeah, like the larger English models are going to be more trained on US-centric ideas, whereas if you are using a native model, say the French model Lyra from Muse API, then it's going to see the world with that French sort of lens and be able to output sort of content regarding that. So yeah, if you're a French business using a French model, then you're going to get a better output than a model which is US centric, right? I think that's really one of the main points.
And also there are some other subtleties, like it's very hard in translation to get something that's like Belgian French or like Quebecois. While in our dataset, there is some of that. So if you prompt with like words that are used in Belgium but not in France, for example, there are a few of them, you can generate like French in the style of Belgian, which is something that's very hard and I think maybe impossible to do with a translation tool because it doesn't have this concept.
Is it possible to fine-tune the Muse API models? And if it is, how would that look, the process?
Yeah, so it is of course possible to fine-tune the models. At the moment though, we don't have an automated process to do it like through an API call. It's on the roadmap, but we don't have a date for this yet. What we have done already quite a few times is clients come to us with a use case, say, okay, I would like to do this, I would like to fine-tune the model for this specific application. Then we discuss if they have data already. It's very easy for us because we just run the thing and then we deploy what we call a skill, that is a spatial fine-tuning of the model, let's say, to do a specific thing. And otherwise, if they don't have data yet, we go a bit back and forth. What do you actually need to understand specifically what are the data that we would need to collect or they would need to collect? And then once the data is there, for us, the process is pretty streamlined, even if we don't have it automated yet. And then in the future, we'll for sure provide an endpoint to do this without ever having to talk with us.
Yeah, that's pretty exciting. There's a lot of sort of confusion in terms of fine tuning and how much data is actually sort of needed to do a fine tune. Is there sort of a sweet spot that you sort of feel like how many examples sort of start impacting them?
It's a very good question. It depends a bit on the task, like how hard what you want to do actually is. In general, I find that starting from 1,000 of examples, you start having like an advantage over like doing few shots, for example, with a properly written prompt. And then up to a few tens of thousands. And beyond that, I mean, more data is always better, but you start having a bit of diminishing return in our experience. Then, of course, it depends on the task. There are tasks where maybe you need 50,000, tasks where 2,000 is enough.
The more complex the task, the more data is required. It's pretty good. Okay, it's good to know. One of the questions that we often get quite a lot is the difference between temperature and top P, and when should you really edit temperature and when should you really edit top P, and sort of the benefits. And it can be quite confusing, and I sort of find myself playing around with these settings as well. So it's something that getting a little bit of an input on would be very helpful for sure.
Yeah. So they kind of do the same thing. Like the mechanism is different, but the end result is similar. So I guess but when you lower the temperature, you get a more spiky distribution. So most likely words are more used. And if you edit top P and you reduce top P, you are reducing to a set of most likely words up to a certain amount of probability. So in the end, what you're doing is, in both cases, you are like excluding unlikely words through a different mechanism. There isn't a definitive answer to this question. Some people say that top P is more useful to edit when you're looking for correctness and factuality. Like you need the answer, the generation to be accurate about what you're asking. And temperature instead when you're like playing on the amount of creativity of the model. It's a very limited set of experiments, so I wouldn't take it as the definitive answer. It's a good start if you need to play with your prompt and with the parameters to see, to find out what you're looking for. What almost everyone agrees is you should never edit them together because they interact in weird ways. Because they are playing on different mechanisms to do the same thing. So in the end, you won't know what's going on. One thing that's useful to kind of prototype at the beginning is choose one and reduce it to be deterministic. So for example, if you have temperature, you reduce temperature to 0. You start from there, figuring out a bit if there are like degenerations, like if there is pathologies, if there are pathologies in the generation. And then from there you build up and you start gradually increasing like the creativity of the model, leaving it a bit more freedom. That's the way most people that like do prompt design, prompt engineering work.
Okay, so start from the most deterministic, and then start upping it and seeing how that affects the output until you sort of get something that you're happy with, and it doesn't go too wild, and that's sort of the sweet spot.
Yeah, exactly.
Okay. The next question we have, I think we've sort of touched on a little bit with the previous answers with the native language models, is why should someone use a native language model over an English model and then do a translation? So I think we sort of touched on, by using the native model, you're getting the model from a specific cultural perspective as well as a language perspective, whereas some of the larger English models will have a very US centric position. If you use a native French one, then it's going to look at the world from a French perspective, and as well, German, Italian, and that's sort of pretty much answered. If there's anything you want to add to that,
yeah, it's a bit the uncanny valley effect, where you have text that generating and it looks like real and good, but there is something weird in it. And if you have a natively trained model instead, it's more natural. Also, another point is it's not like on the comparison between French model, for example, and English plus translation, but if you have instead an English model that's fine-tuned on French data, that can generate French, or even like GPT-3, for example, it has some French in its data, and if you try to prompt it in French, it will somehow work. It won't be amazing quality, but it will be correct French most of the time. The challenge with this, the weak spot, is that since all of these models work on tokenization, and tokenization is like a way to compress language, if you've worked with a tokenizer that's made for English, it has learned to compress English and not French. We work with native French, Italian, and so on tokenizers, which means that for a single token, we get more characters out of it. So since most offers are based on the number of tokens that you consume, like 10 tokens with an English tokenizer could be 20 characters, and 10 tokens with a French tokenizer could be very well something like 50 characters for the same amount of tokens. So that means you're getting like 2.5 times the amount of text than in the other situation. So this is also something that needs to be taken into account.
Yeah, so it could be more efficient, sort of from a user perspective, if they are building out their French needs in the native language compared to using the English, which can end up being more expensive, I guess, by doing that.
Yes, exactly.
Okay, so that's pretty interesting to know, and especially the differences between the different tokenizers. I hadn't really.
Maybe I can make an example so that it's simpler to understand. For example, in French, there is a common expression to say "How are you?" You say "Comment ça va?"
Yeah.
And "comment" is 7 characters, and in French, you have a single token for this word if you've tokenized on French data. If you do it with an English tokenizer, you're probably gonna need 2 or 3 tokens, which means on average, the tokens in English will be 3 to 4 characters, and the token in French is 7 characters. So that means you're getting like a factor 2 in text length.
What are the specific strengths of the Muse API models compared to sort of other models out there? And I think, nailing that with the specific native languages and the tokenizers and being able to do that. But interested to hear your thoughts.
So besides what I've already spoken about, the fact that a native model is much more natural to a native speaker, and also that you get all of the cultural aspects and so on. In terms of data quality that we use to train the models, we are pretty proud of what we've done, it's databases that we've entirely built ourselves, not only, but we've also filtered them with our own techniques in such a way that we try to ensure not only correct, but also safe replies a majority of the time. So at least in our tests, it was very hard to get the French models to be toxic, even when almost looking for it. It's because we filter quite aggressively the data that we've used. Like it's not like we took everything and just made a big thing out of it and that's it. And also in terms of capabilities in few shots and zero shot, I think that in terms of native language models, it's pretty much the best that there is on the market, at least for the French models. We have tried some things, I'm gonna show it afterwards probably, with, for example, chain of thought. I don't know how many of you are familiar with it, but it's a technique where you like try to elicit a reasoning in the model. So instead of just doing few shots, you give examples in few shots, and instead of saying, okay, this review is positive, you say, this review mentions this, and that's why it's positive. And these kind of things have been shown to work only with pretty large models and models that have a certain quality. So when we saw that this actually works with our model, it was like a testament to the quality of what we've done. We were super happy. So yeah,
that's awesome.
That's it.
That again leads nicely into the next sort of question, where we talk more about sort of prompt engineering and putting prompts together. With Riku, we're always trying to help people make good prompts for their businesses and trying to make something very specific for them. And we often get asked, by users where the sweet spot is in terms of how many examples should they include in a prompt to get an output that they want. Is there sort of a number where it generally makes sense, or is it always a case of more data is better? And I imagine for a simplistic task, it's going to be easier for a model to grasp what you're trying to do for a more complex task. But just sort of wanted to hear your thoughts on, what do you sort of see as the best practices for building out a prompt, and is there a point where there is an amount of examples that you can include to make it optimum, or should people just go for as much as they can?
Yeah, so as you say, it depends on the task. So of course, easier tasks are going to be less demanding, and harder tasks will need a bit more experimentation and so on. What I will do is I will share my screen and I will show two examples to illustrate the thing. Okay, so I guess you have my screen. This was the blog post I was talking about before. I'm gonna go on the playground. I just need to minimize the Zoom window because otherwise I don't see what I'm doing. So this is the Muse.Lighton.ai playground. We have some examples, and I'm gonna take one that's to reply to client reviews. It's in French, but don't worry, I will translate for everyone.
Yeah, no problem.
So what we have here is a typical prompt where first thing you have is the instruction, reply to the following client reviews. Then you have the reviews. So we have review and then the review. And the reply, response, and then an example of a reply. We separate the examples with this. Then you can try other things like hashtags and
we like to use hashtags.
Yeah. And then you have the final review to which you want to reply.
Yep.
And I'm gonna just seed the example and put the good parameters so that I can illustrate something. So this 50. Then there is a stop word, this, and then the seed. I want one. One, okay. So now I click on create, it generates the reply. And this was a review, like this pizza place is great. The the welcome was very nice, and we go there very often, and we don't ever want to leave it. And the reply is, we are very happy that you appreciate our pizza place. We are very happy that you've been satisfied with our service. Now, there are a bunch of things that you need to be careful about when you choose examples to put in your prompt, because there are a few different ways the response of the model can be biased by the examples that you choose. For example, in this case, we have chosen one example that's positive, where they say, we are very thankful for your commentary. We thank you a lot, and I hope to see you soon. And one example where we are very sorry that it didn't live up to your expectations. We hope that you will give us another chance very soon. So it's one positive and one negative, which is very important to do when you have these kind of bivalent situations where it can be positive or negative, or like other similar things where you have to choose between two things. If you had put two positive examples or two negative examples, then you bias the model towards what you've put in the prompt. So it's very likely that even if you have a positive review, the model will generate a response that's negative, because you only showed negative replies to the model. So it's gonna think that it needs to reply in a negative way. Or in the opposite, if you only show positive things, it's gonna think it has to reply in a positive way. So this is the first thing to be careful about. And if you have like an odd number of examples, you need to be careful about the most recent one. So if you have 3 examples and you have a positive, negative, positive, well, it's going to be biased twice towards the positive, because first of all, there are 2 positive and 1 negative. Also, one of the things that biases the model is that there is a tiny bit of bias towards the most recent example. So in this case, towards this one, for example. There are ways to address this kind of bias. That it's a technique that's called calibration. So essentially, you ensure that when this thing does not make sense, like you have something like this, the likelihood of having something positive or negative is the same, which if you don't calibrate is not the case. And also the other bias that you can have is what's called the common token bias. So in common token bias, the model is most likely to output an expression that's common. So for example, if you're classifying client reviews in different categories, like this was about waiting time, and this instead was about maintenance. If waiting time is an expression that's much more common in the English language in general than maintenance, I don't know about it, but let's say that's the case, it's gonna be biased towards that just because it's a more common token. And it is also taken care of when you calibrate. And calibration currently is something that we offer for the select endpoint that that you can use to do like classification. But client side, like it's not in the API, but we have plans to put it in the API soon. And the other thing that I wanted to show you about prompting is the chain of thought that I talked about before. So this is another example where we want to determine if the client review is positive or negative, and it's about wines because, you know, French. So you have reviews of wines. This is I'm very disappointed. It's below the standard. I thought from Petit Bourgogne. It's a kind of it's a region. We could have hoped better than that. And then what you provide as example is not simply this review is negative, but you say this client is disappointed and say that the wine is below average. So it says that, this means that the review is negative. And in the same way, you say for a positive review, this client is recommending this wine and it's an excellent quality price ratio. So this is a positive review. So in the end, when we have the last review, I'm gonna remove what I put before as a wait, sorry, that I needed to leave that up. Okay, and I do create. It's gonna say, it's gonna understand what you've asked it, and it not only needs to express like if the review is negative or positive, but also say why. And so it says this client says that the wine is deceiving and it's lacking in intensity and fruit. So here and here, and so the review is negative, which is very cool because at this point you not only get like the classification that you wanted, but also an explanation of why.
Yeah, it's pretty helpful. Like a prompt like this, I do quite a lot with Airbnb properties. So being able to actually know what the cause of like a bad review is, or be able to jump in on that straight away it's a super interesting process for sure.
Yeah, so I think that closes it for the little tutorial on from this side.
So another question that we get asked quite a lot is how difficult it is to add a new language to a large language model. For example, the person who asked this question was very interested in if there would be a large language model which had Indonesian as a language. What sort of process is involved in sort of adding a new language, and does Muse have plans to add different languages in the future? I think there's Indonesian is something that comes up a lot. Also, like Arabic is something that comes up a lot. So I'd love to hear your thoughts on that.
Yeah, so it's all about the data. Like once you have an amount of data that's enough to train a model of a certain size, like there are laws that say if you have a model with this many parameters, you need this amount of data. Once you have that, we've made everything in our code base so that it's straightforward to just repeat the same process for a new language. Like you literally just change the language ISO code in every single config file, and then you run the entire pipeline and you get from data to model, and that's it. Of course, for languages that are like, I don't know, Irish, Basque, this kind of languages, it's very hard because you have very little amount of data. But already for languages like Danish, for example, it's pretty hard to have enough data to do a model that's, for example, of the same size of our French model. But then for like French, German, Italian, these kind of languages, the question, like, yes, you have enough data. For Indonesian, to be honest, I don't know, because there are two aspects to the amount of data that you have available. There is the aspect of how many people speak it, and Indonesian, I think, is like a few hundred millions of people speaking it. But also, how much is it like spoken in a written way, and especially on the web, because that's where most of the data comes from for this model most of the time. And also I don't know about Indonesian, but for example, for Arabic, one of the challenges is that there are many dialects.
Yeah.
And yes, you have modern standard Arabic, but you're not sure that what you actually get on the internet, it's going to be modern standard Arabic. So you need to ensure that's good quality data, that's proper data, and that addresses what you need. We have plans to add many other languages.
There seems to be a lot of different sort of developments in this space, and AI in whole is moving so fast. So one of the questions that we have is, how do you see the future of AI progressing sort of within the next year or within the next 5 years? I know that there has been a lot of developments in image models sort of coming out, and there's even talk of turning image models into videos and all of that crazy stuff. But generally, I'd love to know your thoughts on AI as a whole, and also sort of text-based, sort of text generative sort of AI, and how you see that sort of moving forward.
Yeah, it's a very interesting question. It allows me to talk about something that I'm very passionate about, because there is a lot of talk about how these models are like not democratic, and only big companies can do them, and so on. And I think, yes, it's somehow a problem because it's centralizing some power, let's say. But I think it's also missing something that's when you're from inside the field of AI, you don't actually realize. The fact is that we're pretty excited about these models because we think that their use is much more democratic. Like a few years ago, for example, if you wanted to have something that generates summaries about documents, well, you need to hire an engineer, have him work 6 months on an algorithm to do it, and then deploy it, and then use the solution. And it takes a lot of time, a lot of money, and you need expertise. Now you can have anyone come to you with a text followed by TLDR, and it generates a summary, which means anyone can do it because it's very easy. And this is the case for a lot of applications and a lot of tasks that are central to very often like repetitive and boring jobs without any judgment. Like when you have to generate 50 reports about, I don't know, this stock went down today. I recently talked with someone that said, when I was working in this company, I was super bored because everything I did was I received like a list of stocks in the morning and I had to write a report to my bosses. This thing is so on and so on and so on. And I ended up with a like super complicated program. And if I had this, actually, I could have just created the thing from scratch in no time. I would have had time to do much more interesting things, and my life would have been much better and less boring. So I think a lot of what we'll see is going to be applications of these models to these kind of tasks, and we're already seeing it. And with respect to image that you were mentioning, it actually made me think about something else. Some years ago, I think it was like 2016 or 2017, I remember I went to a meetup with an artist that wanted to teach like Python and C++ to artists so that they would be able to use AI to do their work, because they thought, okay, generative modeling with AI is cool, and now you need to learn the tools of AI to do it. But now, if you think about it, with DALL-E, Imagen, all these models, you just write what you want and you get it. No more need to learn Python or C++ if you're an artist.
Yeah, it's all no code.
And yes, it's somehow scary because it means it changes entirely how your work is going to be done. But I think it's also a big opportunity in removing a lot of barriers. Even when I think about like people with disabilities or this kind of situations, I think there is a huge opportunity to like make their life simpler through these tools. And so yeah, I think this is what like excites me the most, the fact that, like, simply put, now when I talk about my work, my friends understand me, and it was not the case in like 2 years ago. And it's just much more accessible to everyone.
Yeah, I think that's definitely what we're seeing as well, with a lot of people coming to the space with not necessarily a coding background, and trying to do things in sort of like a no code sort of way, which is also sort of the fashionable way to do things at the moment. And I think the future is very bright with the way that people can interact with these models. And I think being able to even sort of create fine-tuned models and bring your own data sets in a no-code sort of way in the future is going to just level up the ability for people to build interesting applications and use cases with this technology. I think a lot of the talking still with a lot of people outside of the space who don't really have any knowledge of it, or tend to go along the path of, is this technology going to put a lot of people out of work? But I think, again, with what you were saying about your friend who was doing the stock reports and having to do that day in, day out, it's a way to really get through a lot of that monotonous, boring sort of work and free up people to do more exciting things. So I don't think there's going to be a shift involved of less of that boring stuff, and companies and staff becoming more efficient at doing other things. And is that really what you think with how this would affect work in the future? Or do you see it sort of, some people see it really as like a catastrophe and there's going to be loads of unemployment, and I don't really see it like that. So I'd love to know your thoughts on that as well.
Yeah, I mean, it's hard to predict the future. In the end, I think there are many many items that will affect how this will go. Not only from a technical point of view, like, are the models actually capable of doing things without any supervision? I don't think it's the case currently. I think it's they work very well when there is human supervision. Like, I personally use the model to write part of the documentation of Muse, like in the guides, but I've used it with me reviewing it and changing what I knew I needed to change and so on. And then, of course, higher quality models are gonna need less edits and so on. But it's always the last 1% that's the hardest, no? So getting to perfection is it's a bit like autonomous cars, where it's always like 5 years in the future. Because
we'd always recommend sort of checking the outputs of all models before you sort of publish, for sure. And I think that editing step is very important, just to get that final centimeter of quality that's needed. Yeah, for sure.
So to me, the point is, I don't think we're technically in a place where we can just let these models run wild without any supervision, especially for some applications. It's dangerous. Like, for example, if you think about health, medicine, and this kind of stuff, it's sensitive. I think they work very well when there is human supervision. I don't think that the availability of this kind of models is anything new in terms of how to say, threats to jobs, because if you want, there are solutions from a few years back that can do the exact same thing with a little bit less quality. But if someone is really only interested in the economics of it and they don't want to hire people, you don't need to have large language models to do this. You can do other stuff and still, like, say, I'm not going to use employees. Then, of course, with the increase in capabilities and so on, yes, we're going to have to make to think about how this is going to affect the job market and so on.
So going back to sort of what we touched on a little bit with the image AI and how that seems to be the next sort of hot property in these large language models. I just thought I'd sort of scratch your brain a little bit and ask about whether you sort of really know about the difference between training such models compared to text-based models. Is there much of a difference? Is there much difference involved in that? Or are they using this similar sort of foundations?
So, interesting question. They share a certain amount of similarity. The underlying model is a bit different, a bit more complex. I have to say that I don't think actually like the structure of the model is the hard part. The hard part is scaling your code base so that you can train this or like a large cluster so that it runs in a reasonable time. And in that case, the techniques that you need to use, if it's text or image, it's kind of the same. There are some trade-offs to make. So probably you're going to make different choices, but the techniques are kind of the same. Then serving the model also poses quite different challenges because dealing with text or with images, it's quite different, especially just thinking about if you deal with text, you might want to do like streaming, give immediately the response and so on, while if you generate images, you can allow a certain latency, like give the response some time afterwards. So it's an entirely different conception of the serving infrastructure. And as for a pure text model, training a model of this kind, it's again a question of data availability. First of all, you need to have the data. Then if you have it, you can train the model. And once again, this means that for some languages, like if you want to prompt a model with Danish or I don't know, Polish, it might be possible or it might be not, depending on the amount of data that are available for this task.
Yeah, it's interesting. I think especially I can't imagine what the size of these image data sets must be, because it must be incredible terabytes, petabytes of data, I imagine, for a lot of them.
Yeah, and clearly it's much larger than text, and also you need to read them in a speed that's reasonable enough to be able to feed your training system fast enough and so on. So with text, this kind of challenge is not there that much because it's a very easy format to read in a fast way, essentially.
Is what areas are the most successful users of Muse working in? So what sort of applications or what sort of use cases are they using Muse for? Obviously, we don't want to go into any specifics, but just sort of, you know, how are they using the API effectively for their businesses and for their workflows? I think that would be interesting to sort of understand.
Yeah. So the first use of the API, even when we had the generation 1 models, so it's like almost 1 year now, was of course SEO copywriting, because it's kind of the immediate application of these models. So that was the first thing that was like a successful commercial application of our models. And it was very interesting to see that the client confirmed that the fact that the model is trained natively in French was part of why their tool was successful. Because like French people are very proud of some things, and so when like especially if you have like there is Mont Saint Michel and you don't know if it's Brittany or Normandy, I never remember, and like they feel strongly about it. So the model needs to be right about that, and English models do not get it right. French models do. then there are also clients that use it to do peer review in language evaluation. So you have someone that writes on their CV, I'm a B2 in English or a C1 in English and so on. And it's a company that provides tests to other companies to verify that the level of English is, or other languages, it's actually that. And so we did a layer of personalization, like fine tuning on top of our English model, so that they could use the model to peer review the evaluations given by actual humans, like professors of English and so on, because that way they can cross-check and see if there is someone cheating the system or this kind of stuff. It's like quality control, essentially. And also we have someone that created a tool to, so it's a browser extension. You go on a website and you can annotate the website. For example, say the margin here is too large, this color does not work, you should use a darker shade and so on. And with the model, you can say, this shade of red is too bright, use a darker shade. And it's gonna generate the CSS code corresponding to like the modification, and then so that they are able to provide immediately the solution to the problem that's described with a certain percentage of accuracy. And yeah, that's it. Then there are a lot of marketing companies that use it to generate cold emails or this kind of content. Content generation for marketing studios, essentially.
Yeah, we see a lot of interest for that, and a lot of companies using.
And now we're also seeing some interest in verbatim analysis. So essentially, the analysis of anything that has to do with the brand, starting from the Google reviews or any other kind of content about your brand. You collect everything and you do a semi-automated analysis. Semi-automated because the model is generating some analysis, and then there is always a human reviewing it and helping it put it in a nice form that's understandable.
Yeah, it's super interesting. I always just get mind blown with all of the different applications and all of the interesting sort of ways that people are applying this technology in so many different areas of business. And I guess it's so broad in what it can do, that it can solve a lot of different issues and problems and speed up different efficiencies. So the future is very exciting, and I'm very excited to see what comes next. I really appreciate your time in helping us to answer those questions for members of our community, and sort of questions that we've got from different individuals. If you have anything else that you want to add, feel free, and I guess we'll start to wrap things up.
Thanks for having me. And yeah, just go to muse.lighton.ai, subscribe. There is a generous free plan that you can use to test things before you actually give us money. And yeah, I'm really interested in seeing what people will build with our tools. It's been very exciting so far to see the random ideas of people coming to us saying, I want to do this, and then successfully doing it. So I'm curious to see what comes next.
Thank you. Awesome.
Thanks, and have a nice day.